Hi guys, and welcome to our next video. This video is the first practical video of our system hacking course, and in this course actually this module is going to represent all the things you need to know about the hacking itself. You know that for that moment we were gathering information, searching for different kind of weak spots or vulnerabilities, and afterwards we were seeking for creating attack vectors and how to actually go for the strategy about that weak spot. Now in this course, in this module, I'm gonna cover exactly that, how you can actually exploit, attack, and actually go offensive to that target. So, but before you actually do that, before you actually go into the details of hacking, how we can get reverse connections, how we can get more privileges, before we can get into this advanced stuff, we should actually understand a few concepts, a few things here, which I'm going to explain it here and actually demonstrate it here. As we've explained before you actually do something, you need to know what exactly you are doing on fundamental level, because many of the things, for example, sending encrypted packets, are not directly visible by us unless we specify a program to listen only for that packet, but it's useless. So many of the things are not visible, and it's hard to actually understand and imagine what's actually happening. So you have to use your creativity, and you have to just understand that knowledge and things. So with the system hacking is the same, because many of the things we would not see, but I'm gonna try to explain as much as possible. And actually, before we get into the part of hacking, we must get into the part of understanding actually Linux and Windows, how those two operational system works, how they manage processes, how they manage threats, what can we do about it, and so on and so on. We have to understand how those two operational systems are working in order to hack them. Sure, it's always easy to actually shoot exploits, run exploits, but that's not what we want. We want to become a professional ethical hackers, the good ones, and the good ones understand those things, and they understand fundamentally the concepts of hacking and actually penetration testing. So as I said, it's always easy to run exploits, but it's not the point. And here we're gonna start this video with actually explaining and understanding some Linux basics about command lines, about permissions, about file structures, and therefore we're gonna go into the Windows one, where we are actually going to explain specific Windows things, and afterwards we can actually start exploiting those two machines. So I hope I was clear. Now we see that I'm logged in Kali Linux, and let's just break that screen a little bit. As Windows, there in Kali, in Linux, and most Linux, we have desktop with icons. Some Linux can actually disable that icons, but this is disabled by the desktop environment. The desktop environment is just the way you see your desktop, the way you see your applications. For example, in desktop environment KDE Plasma, which I use now, we have a terminal emulator called Console. In GNOME or XFace, the terminal emulators are different, but they are doing all the same things. The commands are exactly the same, but they just look different, and they can be actually changed differently. And also there are multiple menus that are not available in other desktop environments. We have here system settings, where everything is structured like specifically for Plasma KDE. If you go for system settings for GNOME, you won't get that settings as I get now, and this is because I use KDE Plasma. So depends on what makes you comfortable. There is no matter what desktop environment you use. The things that can be done with the console, that can be done with the GNOME emulator, that can be done with the XFace terminal. It's no matter. You just need to get used to some desktop environment and stick with that. So for example, I personally like Plasma KDE a lot, because it gives me a lot of pleasure and comfortable place to work with, and the environment is just easy, and you can actually do a lot of management and actually do and create whatever you want and configure it how you want. So now I want to actually specify some basics about a console here. We have the terminal, we have a black screen, and in that black screen is where everything happens. So from here we actually can type commands like help, but if we type the wrong command like some random string, it's not gonna get nothing, because it works with predefined commands. So basically, whenever you install a new feature, a new command is appeared here, and so this is like making a reference, making a shortcut. There is a folder in Linux where every shortcut there is actually can be cast and can be run whenever you are at the directories at the terminal. So I'm gonna explain what's directory, but before that I'm gonna explain what actually can see now. We can see that two strings here. We have root and we have Kali. So what are they? They are just, root is just the current user I'm logged in. When I start up my operational system, it says login and I type root and my password, and now I'm here. So this is like root user, the main user. And afterwards we have Kali, which is basically the computer name what I've set up while installing my operational system. This can be changed, of course, but I used Kali. So this is how computer is actually known at the network, how it's actually known to other machines. For example, when we were scanning the SMB about that machine, we found that the computer name was something like desktop and some random strings. Now this is the same, but I've set up mine as Kali, so if you actually scan that machine, the computer name would be Kali. So this is what it means, root Kali, and now we can go into specified commands and specify command line interface to explain everything that we need. So basically, as we said, here we can type commands like ls, and these commands actually show us what's in the current directory. And what is directory? Directory is just like a folder. For example, let's just minimize that and open home. As you can see, if we actually compare the items, they are exactly the same. We have better cap history. Here we have data, desktop, downloads, enumeration practice. We have the same things because at the terminal emulator, we are at the same directory. So for example, if here I actually create a file with the command touch and give it an extension text, so the text file should appear here, yeah. And now if we get release that with the command ls, we're gonna see that the file.txt has appeared. And if I remove the file from here with the actual graphical user interface with delete button, and now go back and ls again, the file is gone. So you see that with the terminal, I'm at the current directory. If you were using Windows a lot of times, you're gonna stick with that graphical user interface. But believe me, when you get used to the command line, you would not need to even use the graphical user one. So the directory means that the folders, like browsing the folders, for example, home, go to enumeration practice, go back to home, go to root, and there are many folders here which we're gonna explain, yeah, and so on and so on and so on. So while we are clicking with the mouse in the graphical user interface, in the command line is done by the command cd. So when we type cd, we get nowhere. Actually, we get to our users page. For example, when we get to cd desktop, and then we get cd again, we get to our default user page. And I need to explain one more thing. Whenever a user is created, there is a folders generated for him, and there is his desktop environment. This is where all his files can stand. For example, mine one is at POED, which shows print working directory. Working directory means where am I right now, actually, where am I working. So for example, when I create file and delete file, I'm doing that file in our working current directory, and that's why POED is called print working directory. So as you can see, my directory is at /root, so cd /, and therefore we have a directory called root, yeah, here, but that's because I am the root user. If you are a regular user, your directory should be in home, and here there can be many directories about different users. For example, we can create some with the command mkdir. So mkdir user 1, mkdir user 2, and so on and so on and so on. So now we have two folders, and as you can see, all the files of the users should be there, because this directory is system directory. There are all the system files and all the files that should not be touched. This is like the core directory. So the Linux directory is like a tree and the root is at the top. So let me just search for a photo real quick. You know that in Windows we have several partitions, for example C, D, G, and as much as we can. In Linux it's not like that. In Linux just working with one partition, which is the slash, the main partition, the root, and therefore every folders and every directory is actually in Unix based environments or Linux based environments. It's better to call them directories. So all directory starts from root and now actually going below that. So let's search for Linux, actually Unix, search Unix directory structure, go for images, and now you can see that everything starts with the root. The root therefore have several directories, and their directories are actually going down and down and down and down and down. Okay, so there is a better example here and better one here. So you see root is at the very top, and from root everything starts to down below. So it's not like in Windows. In Windows we have C, D, and no matter what happens with the C drive or the D drive, the other one is okay. But here, if everything happens with the root directory, everything is going to crash. It's going to be deleted. So be careful with that. Those types of systems are really crashable and really can easily broke. You can easily break a Unix system, Unix directory system, if you don't know what you're doing. For example, I've did it several times myself. So you have to be really careful what you are doing. But this is how Linux is actually storing its directory, storing their folders. We have one root and everything is going down below. And for example, let's go back here. If we are user 1, we should not be able to get content from that root folder, and we'll be able to modify that folder or create files or execute files. But now we are actually a root user, so for now we are actually the administrator, so-called, in Windows. And from here on out we can do whatever we want. We can even delete the whole root system, but that would completely crash our system and I would need to actually rebuild my system again. So we don't do that, but it's a key thing to know that the users are of course not permitted to touch something here. The only one who can touch something here is the root. So we are now the root and we can do anything we want. The best thing about Linux is that Linux is not giving us the forbiddance, or is not limiting us about doing what we want. We can do almost everything what comes upon our mind, but the consequences we have to pay for them. For example, yes, we sure can delete the whole system without the Linux even warning us about that, but then we have to rebuild our system and we're gonna deal with such data loss. But for example, in Windows, if you try to delete System 32 or C drive, Windows is not going to let you do that. This is why I like Linux the most, because you have the free will of doing whatever you can. So this is how the directories are structured, and as I said, in Unix-based system, and Unix-based means that like before everything, every technology, every Windows and Linux out there, there were only a huge terminal running Unix commands like that. So you can say that before, or actually behind every Linux is standing a Unix, and actually behind every Mac OS. So as you can see, this type of command, this syntax is Unix based. So that we said, that's because we say Linux is Unix based. So it's time to move on, and as we said, it's better to call directories here. So now a few concepts you need to understand: that in Linux everything is treated as a file. Everything, even the directories. They are files, they are treated as a file, files are treated as a file, everything is just a file. And we have a file for everything. For example, we have file for the memory, and that file, for example, cat, we can use cat in order to see the content of the file. So cat proc mem info, and with tab we can actually auto fill the sentence. So mem info, and if there is nothing we are searching for example, and now we type in tab, nothing is gonna happen. So but if we type just the m and see what we can get, we have different options. So we go for mem info, click enter, and you can see that there are all the information about the memory. So in Linux, everything is stored as files. Drivers are stored as files, programs are files. So whenever something is needed from the operational system or some operation is needed, the operational system is going to files, it's asking files, and it's working with files, and it's writing in files. Everything in Unix is files, and it's written on C, so you don't have to actually be amazed by that fact, but we're gonna get that in future. So you have to remember that everything is a file. Directories are just files as well, and they are treated as files as well. They are just files who are collecting more files inside. And whenever you need like a driver or a software, it's a file where you need to actually open and access that file. The operation system is actually going and asking that file for read permissions and actually read that file and then writes whatever is needed. So keep that in mind. Everything here are just files. So for seeing the files, we have several commands like head, and this is going to display the very top rows of the file. And we can use head help, and with help you can see the number of lines that it can be displayed, and by default they are 10. The same thing is used with the tail command, so tail proc, but it's just from the bottom. But if we go tail dash n 20, now we go more, and the same thing with head, so head dash n, we got the very first 20 lines. So it's very simple. We have actually less, proc info, and the less is actually a different text viewer for a terminal interface. As you can see, we can move, if the file is long enough, we can move with arrows, but the file is just too short. And we can exit that using Q command, the Q key. So Q, and now we can clear that. So you need to know that command to see files, text files, because everything, as I said, in Linux is files. And whenever you are exploiting, actually writing exploit, reading exploit, and actually when we are even hacking, when we go to the target machine, we are actually seeing that huge black screen. We don't see nothing else. And we need to actually work with that black screen and be comfortable with it. We cannot hack using graphical user interface because otherwise we would be visible, and this is the most likely thing. So as I said before, while hacking you're gonna see that black screen and you're gonna get comfortable using that screen. So you got to hack safe, and you just need to be very comfortable using that. So there are a lot of commands of seeing files, because most of the times we're gonna work with files and you're gonna know how to read and actually edit them. So for now I just show you basic examples of reading files using cat, less, tail, and head. And in the future I'm gonna show you how to actually you can edit files using nano and vim. And we're gonna cover all the concepts needed there, all the tools and all the questions actually possible. And therefore we're gonna start actually working for permissions, understanding what's permission and explaining what's a permission. So thank you guys for watching, and see you in the next video.